So now the next question is question number 4. We have to find y4. That means we have to find fourth derivative of the given function. And the first part is y is equal to sine 3x. We have y is equal to sine 3x and we have to find this y4. Solution. The first derivative is y1 cos 3x into 3. Just to differentiate this one, as the derivative of sine is cos, angle is as it is, and then we have to apply the derivative on this angle, which is 3. So this one is simply first derivative. Again differentiating, we have y2, this 3 will be as it is. The derivative of cos will be minus sine, angle is as it is, and then the derivative of this angle is again 3, as derivative of 3x is 3, because derivative of x is 1, multiply by 3 will become 3. Now we have y2 minus 9 sine 3x. Again differentiating with respect to x, this minus 9 will be as it is, derivative of sine 3x will be cos 3x, and then derivative of 3x will be 3. So finally third derivative will be minus 27 cos 3x. And the next derivative y4, this minus 27 will be as it is, and then derivative of cos 3x will be minus sine 3x, and derivative of this angle 3x will be 3. So the required fourth derivative of the given function is 81 sine 3x. So this is actually the procedure to find successive derivatives. You have to just apply a series of differentiation one by one, as this one is the given function. Differentiate, we will get first derivative, and this one is first derivative. To find second derivative, we have to differentiate this one, and to find third derivative, we have to differentiate the second derivative. So that will become third derivative, and similarly the fourth derivative is actually the derivative of this third derivative, which will become 81 sine 3x. So the next question, y is equal to cos cube x. We can find our fourth derivative in a multiple of ways. First option, we can remove or we can change this power into the multiple of angle, as we discussed in first year trigonometry, using triple angle formula to convert this exponent in the multiple of angle shape. Solution, as first we try to convert this exponent into the multiple of angle. So cos 3x is actually cos 2x plus 1. Using the formula of cos alpha plus beta, we have cos alpha cos beta minus sin alpha sin beta. And this cos 2x can be written as 2 cos square x minus 1. The sin 2x will be 2 sin x cos x. That will become 2 cos cube x minus cos x. And by using number of steps, we have cos cube x is equal to 1 by 4 cos 3x plus 3 cos x. So this one is actually the conversion of cos cube x, which is equal to 1 by 4 cos 3x plus 3 cos x. We can directly come to this step by avoiding these all calculation work. So just to use this cos 3x formula to convert this exponent into the multiple of angle shape, as this is more easy to find derivative of trigonometric functions with multiple of angle instead of finding derivative with exponent, as we have to use power rule to differentiate such type of function. But the derivative of such type of functions which is in the multiple of angle shape instead of exponent we can easily differentiate such type of functions. So from equation 1, y is equal to this cos cube x will become 1 by 4 cos 3x plus 3 cos x. Now to differentiate, y1 will become 1 by 4 will be as it is, and the derivative of cos 3x will be minus sin 3x, and then derivative of 3x will be 3, plus 3 will be as it is, and derivative of cos x is minus sin x. So we have y1 1 by 4 minus 3 sin 3x minus 3 sin x. Again differentiate with respect to x. So we have y2 in left hand side, and the right hand side will be this minus 3 will be constant, sin 3x. As we simplify or differentiate in our first part, the derivative of sin 3x will be cos 3x, and the derivative of this angle 3x will be 3. Similarly, minus 3 will be constant term, so derivative of sin x will be cos x. So y2 will be minus 9 cos 3x minus 3 cos x with multiplication of this constant 1 by 4. Now again differentiating with respect to x to find third derivative. So we can mention out here differentiate with respect to x. So the third derivative will be this constant term 1 by 4 will be as it is, minus 9, again a constant term, derivative of cos 3x will be minus sin 3x, and the derivative of 3x will be 3. This minus 3 will be as it is, and derivative of cos x will be minus sin x. So simplifying this one, we have y3 or third derivative, which is 1 by 4 27 sin 3x plus 3 sin x. So to find fourth derivative, we have to differentiate this third derivative, differentiate with respect to x. We have fourth derivative, which is y4 1 by 4. This 27 will be constant term, derivative of sine will be cos 3x, and the derivative of this angle will be 3. Similarly, 3 sin x, the derivative will become 3 cos x. So y4 is 1 by 4, 27 into 3 will be 81 by multiplying 27 into 3, and this 3 cos x will be as it is. So as the given expression is in terms of exponent, not in terms of multiple of angle, we just converted this exponent into the multiple of angle shape for our easiness. So at the end we have to convert this multiple of angle into the exponent shape again. So using the formula of cos 3x, in terms of exponent we have 4 cos cube x minus 3 cos x. This is actually the formula of cos 3x mentioned in our previous slide or already discussed in our first year trigonometric formulas. So simplifying this one, y4 will be 1 by 4, this 81 into 4 will be 324 cos cube x, 81 multiplied by 3 will be 243x, and this 3 cos x will be as it is. And finally, to simplifying this one will become y4 1 by 4 324 cos cube, and 243 and 3 will be 240 cos x. By taking common 4 from this expression, we have 81 cos cube x minus 60 cos x. Dividing these 4 will become y4, the required fourth derivative is minus 60 cos x plus 81 cos cube x. So this is an approach to find fourth derivative or multiple derivatives of a function which is in exponent form. But we can differentiate this y is equal to cos cube x in another approach, like y is equal to cos cube x, then derivative or first derivative will be y1 3 using power formula cos square x, and derivative of cos square will be minus sin x. Here we have two trigonometric function. So just before proceeding into the next derivative, we can change this cos square in terms of sine so that we have only first one trigonometric function instead of these two different trigonometric functions. So just to modify this one, that will become 1 minus sine square x into minus sine x. So we have actually y1, which is this 3 sine square by multiplying minus sine x will become 3 sine cube x, and minus sine x will multiply by 1 with 3 will become minus 3 sine x. So this one is first derivative. Now to differentiate this one, we will get our second derivative. In the same process, we have again to differentiate this y1 will become y2. So derivative of 3 sine 3x will be actually 3 is the constant term. Derivative of sine cube will be 3 by using power theorem. Sine 3 minus 1, which is 2, and derivative of sine x cos x. This minus 3 sine x derivative will become cos x. And now we can simplify it again in terms of only one trigonometric function. Instead of these two trigonometric function, we just convert this sign in terms of cos. So that will be actually 9 cos x, and sine square can be written as 1 minus cos square x. And by simplifying this y2, 9 cos square by multiplying minus cos square will be minus 9 cos cube x, and 9 cos x minus 3 cos x will be plus 6 cos x. So again we have only one trigonometric function, so we can proceed into the third derivative by just again differentiating this function. So this is another approach. Instead of using this multiple of angle shape, which we converted this exponent function into the multiple of angle shape, we just applying differentiation directly the given question. So no need of this calculation work or to remember this formulas. So you can use any of these two approaches to solve such type of question. Y is equal to cos cube x, or we can have y is equal to sine cube x. So you people proceed this in the same way to finding fourth derivative.